Hello everyone. I hope you all will be fine, safe and healthy at your home, and I hope you all will be enjoying your online classes. So let us start our today's session. As you all know that in our today's session we are going to start the next chapter. This is of equilibrium, in which we will study about physical equilibrium and chemical equilibrium. So let me explain first of all what is the equilibrium. So you see here what I have written about the equilibrium. It is the state at which the concentration of reactant and the product do not change with time. Suppose any chemical reaction is taking place. Let us consider A is a reactant and after completion of the reaction P product is forming. If there is no change in the concentration of reactant and in the concentration of product, so this condition is to be considered as equilibrium. Most probably it happens whenever the product formation takes place, the concentration of reactant decreases, but sometimes that condition creates this is of equilibrium. So here you have to understand, I have written, it means the rate of forward reaction that is equal to the rate of backward reaction. So here you can write for the reaction that I have considered. A is a reactant, P is the product. So you can write there rate of forward reaction that is equal to rate of backward reaction. Means the rate through which A will convert into the P, this is of rate of forward reaction. When the P is converting back into the A, so that becomes a rate of backward reaction. So most probably that condition is to be denoted by reversible arrow. Okay. So now you see here that we will discuss about some cases about the physical equilibrium and then we will come on the chemical equilibrium in detail. So let us start the conditions to understand the physical equilibrium. So in the physical equilibrium you can see here I have written it is set up in the physical process. Physical process means that can be reversed back. Like suppose solid is converting into a liquid and then liquid will convert back into the solid form. In the same way liquid can convert into the gas during the evaporation and gas can after condensation, then again liquid we get. Now you can see here how the liquid converts into the gas form during evaporation. Okay, when the gaseous molecules they start to condense, okay, when the condensation takes place, then it will convert into a liquid form. Okay, in the same way you can understand how the solid convert into a gaseous form. Gases can convert back after condensation into a solid form also, but solid will convert into the gaseous form through the sublimation. Okay, direct change of solid into the gaseous form. This is of sublimation. Let's talk about the next solid liquid equilibrium. Here I have written the few examples. Rate of melting that is equal to rate of freezing. That H2S water from the solid form that can convert into the liquid form. Let's talk about the liquid gas equilibrium. Rate of evaporation that is equal to rate of condensation. Now see here equilibrium involving dissolution of solid or gas in the liquid. So we talk about if you are preparing or you are dissolving a solid in the liquid, then what condition arises. Suppose sugar in the solution. You have dissolved the sugar, you have prepared the sugar solution, then after that will convert back into a sugar into a solid form. Like suppose you are evaporating the water from the sugar solution, then we will get this sugar in a solid form. Okay, so let us talk about the gas in the liquid. Suppose any gaseous solution that we have prepared in a liquid, so gases can be dissolved in the liquid. Most probably we cannot imagine that gases can be dissolved in the liquid, but it is also possible. Actually at a given temperature a liquid can dissolve only a certain definite mass of gas. So here I am giving the one example. You can talk about or simply you can see the one example in your daily life, like cold drinks. Most probably we had dissolved the CO2 gas. Whenever you open the cap, CO2 gas comes out. Okay, so this is the best example for dissolution of gas into a soda water. So Henry was a scientist. He explained that the dissolution of gas into a liquid form in complete detail. So here you have to understand what he said. The mass of a gas dissolved in a given mass of a solvent. Solvent may be of any solvent, water maybe most probably, and other chemical also like ether, alcohol, they also can act as solvent, at a particular temperature is proportional to the pressure of the gas above solvent. So here you have to understand, like sugar simply can dissolve into a water, but as we have to dissolve any gas in a liquid, so we have to increase the pressure. Actually you must know that all the gaseous molecules, they are very far away from each other, they have almost negligible force of attraction. So if you will increase the pressure, you will put some pressure on the gaseous molecules, so these gaseous molecules will come closer to each other and easily they will be able to dissolve into a liquid form. So simply that the statement arises, mass is directly proportional to pressure, means if we will increase the pressure, the solubility of gas will increase. So that can be written, if we remove the sign of proportionality, then we can write there KH, this is of Henry constant. So overall the solubility of gas is directly proportional to the pressure. So here KH depends on the nature of the gas, liquid and the temperature, that we have to know that. Okay, I hope you all have got it. What is the physical equilibrium and what is the main statement about the Henry laws. That's all for today's session.